Hello, everyone. So today I want to just give a really high-level explanation and quick demo of a recent project that I've been working on, which is the implementation of the Kademlia Distributed Hash Table in TypeScript. Um, I have written an extensive README here that sort of goes over what the algorithm is, how it works, what it's used for in really sort of intricate detail. So to save this video from being too long, because I like to digress, I'm just going to really quickly say what it is, why it's cool, and then show two demos: a simulation demo and sort of a production type demo. So Kademlia is a way of storing information and retrieving information in peer-to-peer systems, distributed systems, or like networking applications. So the sort of key takeaways of Kademlia is it is a real efficient way to sort of locate and gather resources in P2P networks, because how it works is it assumes that each node will maintain a sort of close list of peers that are geographically close to itself in the network. So if I'm joining a distributed system or a node in a peer-to-peer network, I'm going to find what sort of peers are in the network already that are close to myself, and I'm just going to maintain connections with only that list for retrieving information and broadcasting information into the network. And this assumption sort of allows us to come to the conclusion that we can effectively sort of store and propagate information in a network of hundreds and thousands or millions of peers through a very small close list of peers, so that we're not wasting resources trying to maintain connections to every peer in the network. So Kademlia is actually a variant of Kademlia is used in the Ethereum sort of implementation, like Geth and Nethermind and all of these other clients, for peer discovery. So when a node joins the network, they'll use a variant of Kademlia to figure out what nodes to sort of maintain connections to, for either querying the network for getting things like blocks, transactions, and also for distributing messages to other nodes in the network for things like consensus. So, what the demo I'm going to show you now is going to spin up a simulation network of 500 nodes. And what we're going to do is I'm going to show you how we can sort of propagate a message to a network of 500 nodes by only having each node send a message to 20 nodes. So if I run my script, this is going to start the Kademlia algorithm on 500 nodes, and that's what you can see here. I'm not logging much of the key information in this simulation script because there'd be too much logs, because you're not really meant to do this. And what's happening here is each node is running the Kademlia algorithm behind the scenes, and it's a recursive algorithm that pretty much will just go for each node, and they'll go, right, I'm going to ping sort of a handset of nodes, and then figure out from the reply that I get back sort of what peers I should maintain or keep in my shortlist. And then if I want to send messages into the network, I'm just going to ping all of those nodes. They're going to ping all of their neighbors, and so on until the message is propagated throughout the network. And if I want to receive a message, I'm just going to write a query to all of my closest nodes to find the node that is storing the message that I'm looking for. So that's what's happening. I've built a HTTP sort of REST API so that I can interact with my nodes over HTTP, just to sort of make this process more visual. So if I go to, say, node 2000, which is the first node, and I query it, we can see here the network, the short list of networks that this node has. So this node is connected to one, it has 9 of these sort of buckets. So 9 by 4 is 36. So I'm maintaining a connection to 32 nodes, and then like other nodes in the network, like if I go to like node 2500, might maintain as many, just because they're further away from my sort of initial bootstrap node, which is 3000. But what's cool about this now is if I go to, say, like node 2001, for example. So if we get the nodes for node 2001, you can see I'm connected here in node 2001 to actually only 1, 2, 3, 4, 5, 6, 7 nodes, right? Let's just make sure that's right. Yeah. So if I go and I try to propagate a message here, propagating a message. You can see that each node has sent a broadcast message. That's what this sort of message here is. All of these nodes are receiving broadcasts. And now what I can do is this message should be propagated out throughout the network because of the way Kademlia works. So if I go to node 2002 and get the message, you can see it's there. If I go to like, say, let's try node like 2000 or 2020 will do even. Boom, 2020 has it. If I go to like node 2120, boom, we have it. If I go to like node 2200, you can see the message has literally been propagated throughout the network from me sending a message to literally like 10 nodes. So I've propagated a message to 500 nodes by having each node send it to like 10 nodes. I think that's crazy. So that's for my TCP transport or my WebSockets transport. Now, the way that Kademlia stores information in its distributed hash table sort of works a little differently. So I can store a value in my network. So let's say I'm here on here and I want to node 2001. I want to store the value hey. Well, the way that this is going to get stored is we're going to take the hash of the value hey, and we're going to store hey. We're going to figure out what node needs to store this value based on a little algorithm where the algorithm takes the hash of hey and uses the hash of the value to actually store it in the map. So if I want to store a value, it's going to hash the value and use that as the key. And we're also going to figure out what node stores the value by doing a little sort of quick algorithm on the hash of the key as well. So you can see if I store node, or if I've already stored that. So I'm storing it on node 155, but as a failsafe, I also store it on 3 of the other close nodes as well. So now if I go somewhere, let's say I go to like 2100 and I try and find this value, boom, we got it. If I go to like node 2252, say, boom, we got it. And like, let's say I do a different one like hola, or if I store hola, maybe we do it on 2100. Boom, so this one should be stored in 268. We go here, and boom, we got hola. So that's the really cool thing about Kademlia. It's really efficient for storing information. So yeah, that's pretty much my overview of Kademlia. Super cool algorithm. If you want to take a look at the code, README explains all of the more technicals, and then it has a little usage at the bottom. But yeah, that's pretty much it. I'll see you guys. I don't really make videos that much, but yeah.